Good morning, children. Today we are going to study the structure of proteins. Already we have discussed about that proteins are the polymers of alpha amino acids, and they are connected to each other by peptide bond or peptide linkage. Chemically, peptide linkage is an amide formed between COOH group and NH2 group, that is your carboxyl group and amino group. The reaction between two molecules of similar or different amino acids proceeds through the combination of the amino group of one molecule with the carboxyl group of the other. This results in the elimination of water molecule and formation of a peptide bond. This we can see the formation of peptide bond by taking two amino acids, alpha amino acids, glycine and alanine. Glycine minus water molecule, then so this is peptide bond which is formed. In this case, it is being formed between glycine and alanine, and the polymer, here it is your dimer, we can say, is formed, that is called glycyl alanine. Glycyl alanine. So we can say in this way that the product of the reaction is called a dipeptide. A dipeptide because it is made up of two amino acids, and if a third amino acid combines to a dipeptide, the product is called a tripeptide, tetrapeptide, pentapeptide or hexapeptide and so on. And the products, when the number of such amino acids is more than 10, then the products are called polypeptides. A polypeptide with more than 100 amino acids amino acid residues having molecular formula mass over than 10,000 unified mass is called a protein. I hope the formation of peptide bond is clear to you. That is your OH of carboxyl group and H of amino group of one molecule and the other molecule, they combine with each other to form water, and the product thus obtained is called a dipeptide, and the bond is called peptide bond or peptide linkage. Now proteins can be classified into, now let's go for the classification of proteins. Proteins can be classified into two types on the basis of their molecular shape. One is called the fibrous protein. When the polypeptide chains run parallel and are held together by hydrogen bonds and disulfide bond, then fiber-like structure is formed. Such proteins are generally insoluble in water. Some common examples are keratin, which are present in hair, wool, silk, and myosin present in muscles. Then it is your globular proteins. This structure results when the chains of polypeptide coil around to give a spherical shape. These are usually soluble in water. Insulin and albumins are the common examples of globular proteins. The structure and shape of proteins can be studied at 4 different levels: primary, secondary, tertiary, and quaternary, each level being more complex than the previous one. The primary structure of proteins may have one or more polypeptide chains. Each polypeptide in a protein has amino acids linked with each other in a specific sequence, and it is this sequence of amino acids that is said to be primary structure of that protein. Any change in this primary structure, that is the sequence of amino acids, creates a different protein. Secondary structure of proteins. The secondary structure of proteins refers to the shape in which a long polypeptide chain can exist. They are found to exist in 2 different types of structures, for example, alpha helix and beta pleated sheet structure. These structures arise due to the regular folding of the backbone of the polypeptide chain due to hydrogen bonding between carbonyl group and NH group of the peptide bond. Alpha helix is one of the most common ways in which a polypeptide chain forms all possible hydrogen bonds by twisting into a right-handed screw helix with the NH group of each amino acid residues hydrogen bonding to the carbonyl group of an adjacent turn of the helix, which is given in the figure of NCERT book. Even in the figures are given in the side books. In beta structure, all the peptide chains are stretched out to nearly maximum extension and then laid side by side, which are held together by intermolecular hydrogen bonds. The structure resembles the pleated folds of drapery and therefore is known as beta pleated sheet. Tertiary structure of proteins, that is your 3 degree. The tertiary structure of proteins represents overall folding of the polypeptide chains, that is further folding of secondary structure. It gives rise to 2 major molecular shapes, For example, fibrous and globular, the main forces which stabilize the 2-degree, that is your secondary, and 3-degree, that is your tertiary structures of proteins are hydrogen bonds, disulfide linkages, van der Waals, and electrostatic force of attraction. Quaternary structure of proteins. Some of the proteins are composed of 2 or more polypeptide chains referred to as subunits. The spatial arrangement of these subunits with respect to each other is known as quaternary structure. Diagrammatically it is shown. You can take the help of the diagrams. Now coming to denaturation of proteins. Proteins found in a biological system with a unique 3-dimensional structure and biological activity is called a native protein. When a protein in its native form is subjected to physical change like change in temperature or chemical change like change in pH, the hydrogen bonds are disturbed. Due to this, globules unfold and helix get uncoiled and proteins loses its biological activity, and this is called denaturation of protein. During denaturation, 2-degree and 3-degree structures are destroyed, but 1-degree structure remains intact. The examples are the coagulation of egg white albumin on boiling is a common example of denaturation of protein. Another example is curdling of milk, which is caused due to the formation of lactic acid by the bacteria Lactobacillus present in milk. In the coming class, that is on Tuesday, I will give another video on nucleic acids, DNA and RNA. I hope it is clear how the peptide bond is being formed. Is very important from the both point of view. I hope it is clear. Thank you.